All right, so once you're signed into Google Classroom, you will see in the stream this lab activity, Physics 20 Graphing Lab Position versus Time. Okay, if you open it up, which is what you should do, okay, you will see that right now there are two files. Okay, one is just the lab sheet, right? It's your reference sheet. It's the thing I'm going to be going over here on the board. Okay, it's just a PDF. You won't be editing that file at all. All right, then there's this one here that'll have your name on it. It won't say student code error. It'll say whatever your name is. Okay, U1 Graphing Experimental Data Lab Report. That is the file that you will be making your lab report in, and this is the file you will be submitting electronically through Google Classroom to me. Okay, I do not, I repeat, do not accept paper copies. I will only accept this done electronically. Right? If you don't have access to something to type it on, then come in here at lunch or scheduled help where you do have access to something to type it on. Okay, but that's the only way I will accept it. I won't take any paper. So make sure you've got it done electronically. So what you need to do, and I'm sure you're all familiar with this, okay, is just open this up and it'll open up the template. So you'll see that the template is all made for you already. Okay, you just have to fill it in. So your manipulated, responding, and controlled variables. Okay, your hypothesis. Okay, you'll put in your data charts and graphs in here once they're built. Okay, you'll do your analysis. You'll do your conclusion and your evaluation. Okay, all the other information you need for that is in the other lab sheet file, and that's the one that I'm going to be going over. All right, so if you go into that one, okay, it looks similar, okay, except it's got the instructions in it. Okay, so you'll need to refer back to this one occasionally while you're building your lab report. Everybody follow there? Yeah? Okay. All right, so the purpose of this lab is to figure out, using our data on a position versus time graph, the velocity of several toy carts. Okay, so we're going to be running these toy carts across the floor here in the classroom. Okay, not across the entire atrium because we don't need to do that. Okay, and they're going to be modified slightly from the picture. They are going to have this big giant piece of cardboard stuck in behind the seats. Okay, just put it in there. It's because they go so fast that we need this to create some air resistance so they don't fly away. Actually, no. It's just so that our sensors see them better. Okay, having this big thing up there, the sensor sees the cardboard better than it does just the small cart, and we get better data. Okay, they don't lose track of where the cart is as easily. So when you're doing the lab, make sure you've jammed a piece of cardboard in behind the seat so that the sensor will see it. Okay, you can also see that behind the cart in this picture is the sensor. All right, the sensor is a two-part apparatus. Okay, the first part is the actual emitter and receiver. When it's on, you'll actually hear a very light clicking sound, right? This works on essentially a Doppler effect kind of a thing. It makes sound, the sound reflects off nearby objects, and based on the amount of time it takes to come back, it can calculate the velocity, the acceleration, and the position of the object it's tracking. Okay, so you'll hear it make this little popping, clicking sound, okay, when it's actually running. The other part of that is a little Bluetooth transmitter. Okay. So they have to be plugged into each other, and they only go in one way. Okay? They're built so you can't put them in backwards. Okay? You'll connect them and then connect it to your phone. So I'll go through all of that, how that works here in just a minute, but essentially this is going to be the thing that's going to do all the measuring for you. It's going to transmit that data to your phone, and then you are going to send that data to your group mates who can enter it into Google Sheets and build a graph, et cetera, et cetera. So there's basically no manual measurement involved, which really does eliminate a lot of error. Right, so we'll be eliminating a few of those. All right, so again, back to the problem here. The problem, how can the speeds of two different toy carts be determined? Okay, and what we're looking for here, guys, is for you in the problem to restate the problem in your own words as a question. Okay, so you've got to just put that in your own words as a question. That's what you have to do for the problem. Okay, we have to identify our manipulated, responding, and controlled variables. And most importantly, because this is what people do either a poor job of or forget entirely, explain. Okay? Why is this the manipulated variable? Why is this the responding variable, etc. All right, so let's look at the variables here. We are going to be looking at position versus time graphs. Usually, the two things on your graph are your manipulated and responding variable. That way a graph shows you how the manipulated variable, okay, is affecting the responding variable. Everybody follow me there? All right, if we recall back from Science 10, which variable always goes on the x-axis? The manipulated variable always goes on the x-axis. And in every graph we've ever done, that manipulated variable has been time. Okay? Did I just give you an answer there? Okay, so time is our manipulated variable. You need to explain to me why. And I'll tell you this, it's not because we're actually manipulating time. We're not making time run faster, slower, or backwards or sideways. Okay, we're not manipulating in it that way, right? We are simply in control of how long the experiment runs for. Okay, the longer we allow the experiment to run, the farther the cart should go. Agreed? Something along those lines. Okay, and then on our y-axis will be position. Okay, and that'll be in meters. Time will be in seconds. Okay, so obviously, the longer we allow the cart to go, okay, in terms of time, the farther it will travel, or the more its position will change. In other words, position is responding to time. You need to explain how. Controlled variables. You need 3. Okay, you have to identify and explain 3 controlled variables. All right, so for our controlled variables, we require 3 of those. When you are explaining them, you need to explain why they are controlled and what effect they would have on the experiment if you didn't control them. Okay? Controlled variables are anything that could affect the experiment if not kept the same between all trials. All right, so if we're thinking about this one here, where we've got carts running along the floor, okay, and we're trying to calculate their velocity, we're measuring their time and their position, okay, are there some things that could affect the velocity of the cart if we didn't control them? Okay, so you need to think of what are some things that we're maybe not like on purpose controlling, but are like staying the same essentially, okay, while the experiment is going on. So I'll give you one. The surface the carts are traveling on is uniform. Okay? That is, it is not changing during the run. Right? It's not going from floor to ice in the middle of the run, because that would change the velocity of the cart. It would then start to spin and it wouldn't go forwards as fast. Okay? Something like that. Right? You need to come up with 2 more. Explain how they're being controlled and what effect they would have. Okay? Everybody clear on that? All right? That part of your report is 5 marks. Okay? Identifying and explaining the variables is 5 marks. The whole lab is out of 30. Okay? So it's 1/6 of the report. Okay, questions on the design part? Okay, for our hypothesis, what 3 words should be in a good hypothesis? If, and, then. Okay, it's what we call hypothetical deductive thinking. Okay, if this is true, and this is done, then this will happen. Okay, that's how a hypothesis should work. All right, the if part is essentially what you're investigating. The and part describes your experiment. The then part is your predicted results. What is going to happen? What are you going to be able to do? Okay, something along those lines. All right, so in the if part of this hypothesis, okay, we should probably talk about what velocity is. Okay, or what the relationship between position and time is for something traveling at a constant velocity. That might be a better way to say it. Okay, so the if part should talk about the relationship, okay, between position and time for an object traveling at a constant speed. And remember that the basic kinds of relationships are linear relationships, exponential relationships, inverse relationships, okay, or inversely exponential relationships. Those are essentially the ones that we deal with most often. Okay, if something is exponential, then it's like a curve. Okay, if something is linear, then it's a line, right? An angled line usually, right? Things like that. Everybody kind of follow there? All right, so that's what the if part of the hypothesis needs to talk about. The and part is just going to describe the experiment. In this experiment, carts are being allowed to travel along a uniform surface, and their position and time is being measured. Okay, simple as that. All right, we don't have to say much more than that. We don't have to go into detail and go, here's the whole procedure step by step by step. We're just measuring the position as a function of time for these carts. Okay. The then part of the experiment needs to tell me what you're going to be able to do. The problem we were investigating was how we would calculate the speeds of the carts. So the then part should tell us how we're going to do that. Okay, we're going to have a position versus time graph. How can we get the velocity of the cart from that graph? That's what you need to tell me in the then part. Okay. Use a better color here. All right. So that's what you need to have in your hypothesis. Your hypothesis is 5 marks. Okay, so it's 1/6 of the lab report. Questions so far? Okay. I love what you guys are doing right now. Okay, as I'm giving you really big tips and hints, most of you are typing them in. That is a good idea. You could always obviously go back and listen to this recording later, but it'll mean a lot more if you have something typed already. Okay. All right, for the procedure. Okay, it's going to be fairly straightforward. We're just going to have the apparatus set up here, and we're going to allow the cart to run. Okay, if it runs, if you can get good data for around 2 seconds, that's good. Okay, because this thing is going to record 10 points per second. Okay, so it measures a lot. You'll have a lot of data points if it runs for 2 seconds. Okay, much more than you would have had if we'd have run it down the hallway and manually measured it. Okay, so this is going to do a much better job because it's going to give us much more detailed information. So let it run for about 2 seconds. If you're getting good data for more than 2 seconds, great. Okay, but 2 seconds is kind of the sweet spot for getting a good graph. Okay. All right, setting this up. So what's going to happen now is you're going to get that email from whoever sent it in your group, okay? And it's going to contain a file, and it's probably going to be called exported data, right? And it'll be exporteddata.csv. I already renamed it and saved it. What you need to do is, when you get that email, you need to save it in your Google Drive. Okay, so in the one that you get through your school account, right? If you have that set up on your phone, you can do it through your phone. If not, you need to go through the Mail app on the Chromebook, okay, and then save that in your Google Drive with the Chromebook. Okay, there should be a folder in your Google Drive for classroom and then one for this class. Just save it in there. Okay, once you have that, okay, then you can open it in Google Drive, and it'll look like this when you open Google Drive. Okay, it'll say graphing data, whatever you name it. It'll say exported data if you don't change the name. Okay, what you want to do then is right click on it, which on the Chromebook is 2 fingers on the mouse pad. Okay, that's the equivalent of right click. Okay, so right click on that and it'll ask you what you want to open it with. You want to open it with Google Sheets. Okay, and it'll turn this CSV file, which stands for comma separated values, into a spreadsheet. All right, so if I do that, it's going to do a little thinking, or a lot of thinking, and it's going to spit this out. And you're going to look at that and go, oh crap, what am I supposed to do with all that? It's okay. Okay, there's a lot of it that we don't need, and there's a lot of it we're going to delete. We only need the time and the position. And really, we only need the time from the first run because the time is the same for all the other runs. Okay, we're just going to use the time column from the first one. So here's the stuff that you're going to want to delete. And again, you're going to be able to watch this again if you can't do it right now. Okay, I don't need the date and time. Okay, not important. So I'm just going to click on that row and say, or column, and say delete that column. I do want to keep the time. That's important. And I want to keep the position for run 1. Those are important things. I'm going to keep those. I do not need the velocity for run 1. So I'm going to get rid of that. I also don't need the acceleration for run 1. So I'm going to get rid of that too. I don't need the date and time for run 2. So I'll just click on that arrow and get rid of that as well. but I will keep, and I don't need the time for run 2 either, because it's the same as the time for run 1. Okay, so I'm going to get rid of it. I'm going to keep this column. That's the position for run 2. I need that. Okay, and then I'm going to get rid of the velocity for run 2 and the acceleration for run 2. So there's a lot of stuff there that we didn't need. This is what we do need in the end. Awesome. Yeah, if you had like one run that you're not going to use, delete all the stuff. Oh, yes, you can. In fact, rather than delete the whole row, because that'll delete the time, is just delete that particular one. Leave that box empty. Google Sheets will know what to do. It just knows there's no value for that Y or for that X. Okay? All right, so that's what you have to do, guys. If you had an erroneous point, and you'll know because you can see kind of the trend here, like, okay, the cart didn't move in this trial here for quite a while. Okay, I'm going to want to get rid of all this stuff where the cart was stationary and shift it up. Okay, and you can do that. Okay, I'll show you how in just a sec. For this one, for run 1, it worked perfect right from the start. I don't need to do really anything with it. Okay, it looked pretty good all the way along. Maybe at the end there's something I'll need to take out, but the best way to find out what you need to take out is to build the graph. Okay, so build the graph first. One of the things we want to do before we build the graph is get rid of this first row, right? But in order to do that, we better label that this was the position for run 1 and that this one's the position for run 2 before we delete that first row. It's just because Google Sheets gets confused if I leave that stuff in. Okay. All right, so now I've got the data that I need to graph. Okay, so I'm just going to click and drag and highlight all of it. Okay, I know this data here kind of goes beyond, and that'll be okay. Actually, here's what we'll do. I'm going to delete this data here first. Okay, so I'm going to delete the cells that I highlighted there, and then I'm going to shift up. That'll bring all the other data up to the top, okay, kind of where I want it to start. Okay, so I do that, and there we go. So now I've got good data, okay, all the way along. Now I'm going to highlight it all, okay, and I'm going to go to Insert. Okay, and then I'm going to insert chart. So hopefully you did this in Science 10. If you're in my Science 10 class, you've done this before. Okay, insert chart. And then it always picks, Google Sheets always picks some weird chart format that we don't want. Okay, and this new chart editor sucks. So we're going to go to use old chart editor down here in the bottom right. Okay, so first off, what we want to do is change what type of chart it picked up. Okay, those are the recommendations. I don't want any of those. I'm going to go over to chart types, and I'm going to scroll down till I get to scatter. Click on scatter, and now we've got what we want. Okay, our points lined up nicely. Okay, there aren't even any erroneous points here to delete now because I've already done that. Okay, so I'm going to leave it there, and then I'm going to go to customization. And this is where you put in all your stuff. Okay, like a title for the graph. Okay, so like graphing lab position versus time or something like that. Okay, we're going to leave the legend over there on the right because that's usually a good spot for it. Okay, my horizontal axis already has the label with units on it, but my vertical one does not. So I'm going to put that on. Left vertical title is position, and with the units, meters. Okay, so that's done now. Now I have a graph that kind of looks good. Now I need to put my trend line on, okay, or my best fit line. Google Sheets will do that for you. So you scroll all the way down to the bottom, okay, and you see that there's trend line down here at the very bottom. Right now it says none. What do I probably want, linear or exponential? Linear, right? These are pretty in line with each other. So I'm going to go to linear. Okay, and it put it in there, but yeah, I can't see it because the dots are too big. Okay, now the dots are a little smaller and I can see my best fit line. And once I put that line on, I have some other options, okay? This is the most important part. I need the equation for this line in order to do the rest of the lab report. Okay, I need y equals mx plus b for both of those lines. So where it says here, label, use equation. Okay, you want to pick use equation, and it spits out, here's m, x plus b. All right, it just doesn't say y equals, but this is m, this number here is m, x plus, and this is b. All right, so you have that for that line. You're going to do the same thing for the red line. So you have to go back up to series and click the other one and do the same thing. Okay, I'd make the points smaller. Okay, go down to trend line, linear, and then tell it to put the equation up there. All right. So according to this graph, okay, I've got speeds on there now. I know what they were. Okay, I can compare the two carts if I want to. Okay, that graph is done. All right, now we're going to click update, and I've got that graph in. Now I can copy that over into my lab report, and that's what you're going to need to do. Okay, you're actually going to copy two things over to your lab report. You're going to copy the chart first. Okay, so I'm going to go up to here and copy all my data over into my lab report. So, okay, so I'm going to go copy. So just Control C, and I'll just open up a Google Doc here. Okay, and I just Control V, and that chart will come over, and I do want to link it. That way, if I make any changes after I paste it in, it updates them automatically. I don't have to change it twice. Okay, it's pretty slick. All right, so paste it in. All right, so there it is. The labels are all in place, and then I'm going to do the same thing with the graph. I'll go back to my spreadsheet, click on the graph, click up here on the three dots, copy chart, go back over to my lab report, link it, boom. Okay, I've got all my data in my lab report. Now I can do my analysis. Austin? No, just the graph. Okay. Questions there? All right. If some come up while you're working, just call me over, and I can give you a hand. Okay. All right, so for your analysis, okay, there's not much there. It says, using the spreadsheet software, plot your graph. So you're doing part of the analysis right now and plotting a position versus time graph, okay? And using y equals mx plus b, determine the velocity of both cars. So what you need to do in the analysis is show me y equals mx plus b manipulated for velocity. Whichever part of y equals mx plus b is the velocity of the cart, show it for both cars, manipulated for that. Okay, that number is already, spoiler alert, spit out for you by Google Sheets. Okay, so all you have to do is show me the equation manipulated for it, and then explain to me why that's true. Okay, just put in the analysis. The equation is now manipulated for this. This represents velocity because. Okay, and give me about like a 2-sentence explanation as to why you've done that and why you think that part of the equation represents velocity. All right, that's what you have to do for the analysis. Then in your conclusion, okay, copy and paste your hypothesis from the beginning, and then give me an explanation as to why you can accept it or reject it. Were you able to calculate the velocity? How did you do it? Is that valid? Okay, that kind of thing. Your explanation for accepting or rejecting should be a couple of sentences, like 2 or 3, okay, sentences as to, here's my data, here's what it says, here's my analysis, here's what I did, and this is why it supports the hypothesis. For your evaluation, you need 2 sources of error and ways to fix them. All right, sources of error are things that were within the experiment that were beyond your control that had some effect on the experiment that there was nothing you could do about. All right, that does not include the electronic data gathering equipment, because people always try and say, well, that stuff didn't work. Actually, it worked just fine. Okay, just talk about some stuff to do with anything that could affect the velocity of the cart that you couldn't take into account or something like that. Okay, those could be sources of error. All right. Questions on that? Okay, so I have it due on Tuesday, okay, February the 13th. So you got lots of time to work on it. Okay, you can come see me in scheduled help today, tomorrow, or Monday. Okay, but it is due at the start of class on Tuesday.